In this chapter, we will learn how to find the slope of a line that is passing 2 points. So, for example, let me draw a straight line like this, and this line, select any 2 points. Any 2 points is fine. And let's say the coordinate of this x coordinate is x1, and the y coordinate is y1. And the x coordinate of the second point is x2, y coordinate is y2. Then we can draw horizontal line and vertical line like this. Okay. The slope, usually we write slope m as a slope. Then the slope is rise over run. And rise means rise is the vertical distance between 2 points. Vertical distance. So y2 minus y1. So that is called change in y. Actually, the change in y, right? Change in y. Over run is the change in x. So change in y is the vertical distance, y2 minus y1, over change in x is the horizontal distance, x2 minus x1. Okay, so this is the slope. So slope of a line is change in y over change in x, rise over run, y2 minus y1 over x2 minus x1. And in this case, x1, y1 is on 1 point, and x2, y2 is the second point. So that's the slope. Okay, then let's find the slope of 2 points. Okay, if 2 points are 1, 2, and 4 and 5. Okay, here are 2 points. Then what is the slope of this line? The slope of this line. Alright, the slope. Let me just plot this point. So x equals 1, y is 2. X equals 4, y is 5. So here is a straight line connecting these 2 points. Then what is the slope? Slope is rise over run. Rise over run. Rise is 5 minus 2, so 3, and run is the run part. The horizontal distance is 4 minus 1, which is 3. So the slope of the line is y2 minus y1 over x2 minus x1. Rise over run. y2 is 5, y1 is 2, x2 is 4, x1 is 1. Then 3 over 3. So the slope is 1. Slope is 1. Okay, then let's try another example. Okay, here are 2 points. -1 and 4. Another coordinate, another order pair is 2 and 1. So the slope is y2 minus y1 over x2 minus x1. Rise over run. So 1 minus 4 over x2 minus x1, -1. Then -3 over 2 plus 1. So -3 over 3, which is -1. So the slope is -1. Okay, let's plot these 2 points and connect the line. X is -1, y is 4. X is 2, then y is 1. Connect these 2 points like this. So the slope of this line, is -1. Okay, look at this. If the sign of the slope is negative, if it's a negative number, then the right end of the line is going down. So as x increases, y value decreases. Okay, how about this example A? This example. The slope is positive. Then look at the end of the right side of this line. So the right end is going up. As x increases, y also increases. So if the slope is positive, if the slope is positive, then the graph, the straight line, the right end of the line is going up. If the slope is negative, then the right end going down. How about let's try another example. This example 2. What is the slope of these 2 points? Okay, then the slope is y2 minus y1, rise over 1, x2 minus x1. So 4 minus 4 over 3 minus 1, 0 over 2 is 0. So the slope is 0. Okay, then if you plot this point, okay, x equals 1, then y is 4. X equals 3, then y is also 4. Connect these 2 points, then this is the horizontal line. Horizontal line. So the slope of a horizontal line is always 0. Slope. So if the slope is 0, then what? If the slope is 0, then the line, straight line is horizontal line. Okay, let's try the vertical line in this case. So another example is, okay, there are 2 points, 3 and 1 and 3, 3. Okay, then the slope of these 2 lines is y2 minus y1 over x2 minus x1. So 3 minus 1 over 3 minus 3, 2 over 0. If the denominator is 0, then the value is undefined. So which means we don't know actually. The number is not given. So let's plot this point. Okay, x equals 3, then y is 1. X equals 3, then y is 3. So connecting these 2 points is a vertical line. The vertical line. So the slope of a vertical line is always undefined. Slope of vertical line is undefined. So let me write it over there. So if the slope is undefined, then the line is what? A vertical line. So please keep in mind that there are 4 types of straight lines. One is right end is going up, then the slope is always positive. If the right end of the line is going down, then the slope is negative. If the line is horizontal, then the slope is always 0. If the line is a vertical line, then the slope is undefined. Okay, in this example 3, okay, in this case, we can write an equation in slope-intercept form. Okay, slope-intercept form is always y equals mx plus b. And the coefficient of x is the slope. Always this is the slope. So slope is rise over 1. Okay, and plus b. And this b is the y-intercept. Why this b is the y-intercept? If x equals 0, okay, y-intercept, you get the y-intercept when x equals 0. So if x equals 0, then this mx is 0. Then you get y value equals b. So this b value is the y-intercept. When x equals 0, then y value is b. So slope-intercept form is always can be written as y equals mx plus b. So we can graph equation, linear equation using slope and the y-intercept. Let's say y equals 2/3 x plus 1. Okay, then how do you sketch the graph of this linear equation? Okay, the slope is 2/3. So 2/3 is the slope m, and 1 is the y-intercept. Y-intercept. So x equals 0, then y equals 1. So we can sketch this one starting from the y-intercept. So the y-intercept is x equals 0, then y is 1. So let's start from this point. So let's find the second point using the slope. The slope is 2/3. 2/3. So 2 is the rise. Rise the vertical distance between 2 points. 3 is the horizontal distance between 2 points. So here's the first point. Rise, the value of the rise is 2. So I'm going to go 2 units vertically up. Now positive 2 means go 2 units up. Positive means go up. So move 2 units vertically. And the horizontal distance is 3. Positive 3 means move 3 units horizontally to the right. Positive means to the right. So 1, 2, 3. 1, 2, 3. Then this is the second point. So the coordinate of the second point is x value is 3, y value is 3. Connect these 2 points. Then this is the graph of this linear equation. Okay, in this example, let's do the same thing. We will graph this linear equation using the slope and the y-intercept of this equation. So what is the slope? Okay, to find the slope, we have to rewrite this in slope-intercept form. Slope-intercept form. So 12x plus 3y. Slope-intercept form is y equals mx plus b. So let's rewrite the equation. So move 12x to the right, and 3y equals negative 12x plus 6, and divide each side by 3. Each side by 3. Then y is equal to negative 4x plus 2. So we just rewrote the equation in slope-intercept form. Then from this equation, the slope is negative 4. And the y-intercept is when x equals 0, y equals 2. Then plot the y-intercept, x equals 0, y is 2. Then from this point, let's move horizontally and vertically. So the slope is negative 4. The slope is negative 4, which means negative 4 over 1. Then negative 4 is the rise part, and 1 is the run part. So rise is negative 4. The value is negative 4. Negative means vertically move down. So I'm gonna move 4 units down. 1, 2, 3, 4, negative 2. And then the denominator is 1. So move 1 unit to the right. 1 unit to the right. Then this is the connect these 2 points. Then this is the graph of the linear equation. Okay, I didn't graph clearly, so like this. So what's the slope? Negative 4. So we have 2 points. One is the y-intercept, and the other one is moved 4 units down and 1 unit right. In this example, let's sketch the two graphs for each equation. So from the first equation, okay, let's plot the graph on the same coordinate system. Okay, from this one, the y-intercept is 0 because 2x plus 0. So this is the y-intercept. Then the slope is 2. The slope of the first equation is 2, which means 2 over 1. So rise is 2, so move 2 units up, and then run is 1, so move 1 unit to the right. Okay, this is the graph of the first equation. How about the second equation? the y-intercept is -3. -3 is the y-intercept. From this y-intercept, let's find the second point. The slope is 2, which is same as the previous one, the first equation. So move 2 units up, and then 1 unit to the right. 1 unit to the right. And then connect these 2 points. Okay. So since the slope of 2 lines are same, slopes are the same, these 2 lines are parallel. So since 2 lines are parallel, they never intersect each other. Okay, let's try another example. Okay, in this example, we will find out whether 2 lines are parallel or perpendicular. So this is how we can find out. Okay, let's say this is the line 1, line 2. Then the equation of the line 1 and line 2 are parallel if the slope of the first line is equal to the slope of the second line. So let's say M1 is the slope of the first line. Then this slope has to be same as the slope of the second line. Then 2 lines are parallel. Okay, this is a parallel symbol. How about perpendicular? Here's a line 1. Let's say the slope of the line 1 is M1. Slope is M1. And here is a perpendicular line. A perpendicular line means they form a 90 degrees. Then let's say the slope of the line 2 is M2. Then if 2 lines are parallel or the perpendicular, then the product of 2 lines, product of 2 slopes is equal to -1. Then 2 lines are perpendicular. Okay, this is the perpendicular symbol. So if the product of 2 slopes is -1, 2 lines are perpendicular, or vice versa. If 2 lines are perpendicular, then product of 2 slopes is -1. Or we can do this way. M1 times M2 is -1. If you divide both sides by M2, then M1 is equal to -1 over M2. So this is the relationship. If a slope of one line is negative reciprocal, this is reciprocal of M1, M2, slope of line 2, then 2 lines are also perpendicular. Okay, for example, let's do the example of the perpendicular lines. Let's say the slope of line 1 is 2/3, and slope of the second line is -3/2. Then are these 2 lines parallel or perpendicular? Okay, let's multiply the slope, 2 slopes, multiply 2 slopes, then this is equal to -1. Cancel out, -1. So since product of 2 slopes -1, 2 lines are perpendicular. Okay, let's do an example. Example 6. Okay, here it is line 1. Okay, there are 2 linear equations. Y equals 1/2 x plus 1. So let's check if these 2 lines are perpendicular or parallel or neither. Okay, so what we can do is we can compare the slopes. So the slope 1, the slope of the first line is -2, slope of the second line is 1/2. Since these 2 are different, line 1 and line 2 are not parallel, not parallel. Okay, how about product of these two? Negative 2 times 1 over 2 equals negative 1. Okay, since the product is negative 1, yes, line 1 and line 2 are perpendicular. Okay, let's try another example. Here is, okay, the first equation is 1/3 x plus 2. The second equation is 1/3 x minus 3. Okay, the slope of the first line is 1/3. Slope of the second line is also 1/3. They are same. So we can say that two lines are parallel. Okay, let's try another example. Okay, let's say L1, line 1 is y equals negative 4x plus 6. Line 2 is y equals negative 1/4 x minus 1. Okay, are these two lines parallel? Perpendicular? Neither? We don't know yet. Let's compare the slope. So the slope of the first line is negative 4. Slope of the second line is negative 1/4. These two are different, so line 1 and line 2 are not parallel. Okay, how about product of these two? Product. So negative 4 times negative 1/4 is equal to positive 1. This positive 1, not negative 1. This is not negative 1. So this is not parallel also. So this line 1 and line 2 are neither parallel nor perpendicular. Okay, let's try example number 53. Okay, in this example, we're going to find the y coordinates of one point so that the slope is 3 over 2. Then how do we find these y coordinates? Okay, let's use the slope formula. Slope formula is y2 minus y1 over x2 minus x1. This is slope formula. And this slope is equal to 3 over 2. What we can do is we plug in all these four values. So y2 minus y1. y2 is 3. y1, this is y1, is unknown value, y. Okay, over x2 minus x1. x2 is 9 minus x1 is negative 3. So this is equal to 3 over 2. So from this equation, we can find y. So 3 over y, 3 minus y over 9 plus 3 equals 3 over 2. 3 minus y over, the denominator is 12, is equal to 3 over 2. Then from this equation, we can use cross multiply. Then 2 times 3 minus y equals 12 times 3. Then you can distribute or you can divide by 2. Okay, in this case, let's distribute. So 6 minus 2y is equal to 36. Then negative 2y equals, okay, minus 6 both sides. Then 30. Then y equals negative 15. So the y coordinate of the first point is negative 15. Okay, let's do the similar examples. This time we will find the x coordinate of the second point. The slope is given, so let's use the slope formula. Slope formula is y2 minus y1 over x2 minus x1. And this slope is equal to negative 2 over 3. Plug in all these four numbers, 4, 5, 7, and x. So y2 minus y1 is 7 minus 5 over x2 minus, x2 is the unknown variable x, so x2 minus x minus 4. This is equal to negative 2 over 3. Then let's find x. So from this equation, we can use cross multiply. Before we use the cross multiply, let's simplify this. 7 minus 5 is 2 over x minus 4 equals negative 2 over 3. Now let's do the cross multiply. Then 2 times 3 equals negative 2 times x minus 4. Multiply this whole denominator. by negative 2. Okay, then this is equal to 6 equals negative 2 times x minus 4. You can distribute 6 equals negative 2x plus 8 and minus 8 each side, and negative 2 is equal to negative 2x. Divide each side by negative 2, then 1. So the x coordinate of the second point is 1. Okay, then from here, can we try different methods? Yes. Okay, from here you can divide each side by negative 2. Then x minus 4 equals, cancel out, negative 3. Plus 4 each side. Then x equals 1. So the x coordinate of the second point is 1. We get the same answer as this.